Hi everyone, today we're going to talk about the fundamental theorem of algebra and one of the corollaries that's associated with it. The fundamental theorem of algebra says that every polynomial equation with degrees greater than 0 have at least one root in the set of complex numbers. You guys have investigated this in Algebra 2 and we're going to touch on it today and take it a step further a couple days from now. Degrees are the maximum number of times a graph may cross the x-axis. So here's our first three examples. Here's a linear equation. It has a degree of 1 because the highest power of the variable x is 1. This can cross one time and will always cross one time. Here we have a parabola. So we've got a quadratic equation. It has a degree 2. The largest power in the polynomial is 2. So that is why it's a degree 2. And we have a possibility of crossing the x-axis in two places. Right here and right here. So those would be the solutions and or roots. Here's a degree 3. As we talked in the last chapter about end behavior, it's an odd degree. So the ends are facing in opposite directions as x goes to positive and negative infinity, whereas our parabola is an even powered degree, so they are both going in the same direction as x goes to positive and negative infinity. If we take a look at a couple other examples, here's a degree 4, a degree 5, and a degree 6. Like we said earlier, this is a maximum of 6 because you could have a situation where the graph maybe only has 1, 2, 3, 4 x-intercepts. You could have it when it only has 2 x-intercepts or 1 x-intercepts or possibly 0 x-intercepts. That means no roots are going to be real numbers. You would have 6 possible complex numbers that may be imaginary. A corollary to the fundamental theorem of algebra says that every polynomial function p of x of degree n, where n is greater than 0, can be written as a product of a constant k and n linear factors. Therefore, polynomial equations of degree n have exactly n complex root, namely r sub 1, r sub 2, r sub 3, all the way to r sub n. And if you look at our polynomial function, it's in the form x minus your root, x minus your second root, x minus your third root, and all the way unto your last linear factor. And that's it.